We're good to go. Hello.
Hello.
All good?
Yeah.
Okay. So we've got 3D Pythagoras and trigonometry. Someone asked for.
Yes, that's right.
And we were saying before, it might not be the most common thing in a, well, probably unlikely to come up in a non-calculator exam. But you're also saying that we have to know about exact trig functions and also exact Pythagorean triples.
Mm-hmm.
So they are coming, but maybe not so much the 3D. But we'll do it anyway.
Let's try.
Yeah? Okay. So 3D trigonometry or Pythagoras, it could be both, it could be one. We'll have a look. So if we have, where's the pen? Oh, there we go. Cool. And let's choose red, it seems to work nicely. So we need to work out, it says a string runs diagonally across the box from A to G, and I'll just do that in red. Oh, the pen feels a lot nicer, actually. There we go. Calculate the length of the string AG. So looking at it, we were having a look and seeing how we can best describe it before. Because the diagonal runs from the front to the back, it's kind of, that's what makes it 3D. And so we can form a right angle triangle here, but it's not going to be on one plane. I think that might be the best way to explain it. So again, so we can form a right angle triangle, but the base AC runs from back to front, and our right angle triangle is here. Mm-hmm. So what we already know of this right angle triangle, I'm not going to draw it actually, we know that the height of it is 3 centimeters, and it's asking us to work out the hypotenuse, which is AG. In order to do that, we're going to need to know the base AC. Yeah? Mm-hmm. Yeah. So to work out the base AC...
I forgot that they can't see me when I nod.
I know, you're just nodding there and look like a bobblehead. Insults number 5.
Yeah.
Mark it. So to work out the diagonal AC, we can form another right angle triangle using the base of our cuboid. And although it looks a little bit distorted, that's also a right angle triangle.
Yes, because the base is a cube, rectangle,
yeah.
Even.
So it will look a little bit like this. And what we know that this is AC, which we're trying to work out. We know that this is 6 centimeters, this is B, and this is 4 centimeters. So we need to choose what we're going to use. We're going to choose what we use. I like it. To work out the length of AC, Pythagoras or trigonometry. And...
Yes.
Should we try again?
Go on, ask me, sir.
What do you think we're going to do and why, miss? Which one do you think we're going to use and why?
I think we're going to use Pythagoras, sir, because we don't have an angle.
No, wow, that's a textbook answer. Textbook answer. Where did it come from?
We've rehearsed repeatedly before this, guys.
You have. You have. So to work out the length of AC, there's no angle involved apart from the right angle, so we're going to use Pythagoras. And then you always have to choose, am I working out the long side, the hypotenuse, or the short side? So this is long side. And do we add or take away if we're doing long side?
We are adding.
So I always just think if I'm working out AC squared, it's going to be equal to the 2 short sides squared added together. So 6 squared, so I was going to write centimeters, but there's no point, plus 4 squared. 36 plus 16, which is that 52?
Yes, maybe, I don't know, because I did the whole thing in one go.
Okay, so AC squared is equal to 52. So AC is going to be equal to the square root of 52, which is?
7.2111.
And I always tell my kids not to round up. I always just say leave whatever you have in your calculator and see if you can use it for your next. But do you have different advice?
I would say if they ask for 3 significant figures, you should work with 4 and then round the final answer to 3.
Okay.
However, what Sir says is really the best possible way. Just work with the answer.
Thank you. No, if you don't need to clear it off your calculator and you can use it, then why not? Yeah. And it makes life a little bit easier. So in the calculator, it's still got the long version of 7.211. Let's see if we need to use that. Mm-hmm. So we can say now that this over here, between A and C, is 7.211. And if we now go back to the red triangle, and I'll just draw it here.
You like your colour coding, don't you?
Yeah, why not? You know, I was born in the time where we had black and white TVs. I'm very old. No, and so... Same. Yeah, I know that. No,
I know exactly what I'm talking about. Sir, you're just putting me down today.
You're leaving yourself as an easy target. So we know that this is 3 centimeters moving swiftly.
I'm just beside myself now.
I'm trying to...
Sir's not here yesterday and not today. He's like verbally abusing me.
I wouldn't call it verbal. This is called banter. So this over here is 7.211. And so we're going to use Pythagoras or trigonometry to work out the length of AG, miss.
We are going to use we are going to use Pythagoras because we don't have an angle.
And she's doing a robot dance while she's doing it. Okay, so again, we're working out the hypotenuse. We're going to use Pythagoras. Therefore, we're going to add the other side squared. So AG squared is equal to 7.21 blah, blah, blah. And that's still in my calculator. Plus 3 squared. So if I just do that now, jeez, got to do everything myself these days. If I square those together and add them, so plus that, oh, you get exactly 61.
Ooh.
Oh yeah, because obviously the square, of course. See, that's why it's good not to. So that's equal to 61 exactly if you didn't round up before. So AG is equal to the square root of 61, which is. Thanks, Mrs. Stanescu. Is 7.810 blah blah blah, and so it wanted it to 3 significant figures, so round to the
with
third.
The blah blah blah.
Blah 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 blah
here.
blah. 7.81 centimeter, and that's the length of the string AG.
Good.
All good?
Yes, I think. This is a really good one. The problem people are having is usually with angles between a plane, side and a plane, or 2 planes and stuff like that. We're gonna see if we can find something like that to do. But in the meantime, good luck with revision, and we'll see you later.
Bye.
Bye.